everyone. Today I'm going to talk about thermochemistry. First, there's two types of energy. The first one is potential energy, and another one is called kinetic energy. Potential energy is something that is a stored energy, while that is not, you can't see it, so it is not released yet. But the kinetic energy is the energy that is released. For example, like the things is in motion, like this, okay? And chemical potential energy. So chemical potential energy stores the chemical bond for the substance. For example, like running a car, you burn the gasoline, okay? So potential energy is transformed to the first one is kinetic energy. Why? So the car move, right? So it's transferred to kinetic energy, so the car move. And another is that called heat energy, because that the engine is hot, it releases heat. What is heat? Heat is the energy that can transfer from one object to another, so it's a fluid from high temperature to lower temperature, okay? And it's just fluid until that the object has the same temperature. What is the thermochemistry? Thermochemistry is a study of energy that changes during chemical reactions, okay? During the change state. So when a chemical reaction occurs, some chemical bond broken, a new bond form. So the total chemical potential energy of a system is either increase or decrease. And first, the law of conservation of energy. Okay, so first, let me see. So when a physical or chemical reaction occurs, the general, okay, so they transfer energy, okay, and the law of conservation of energy says that any physical or chemical process, the energy is neither created nor destroyed, okay, and the system and the surrounding. The system is the things you are doing experiment, okay, and the surrounding is surroundings, okay, is the place you do, okay, the experiment. For example, yes, so in a laboratory, and then you just do a reaction. So the surrounding is not the reactant, but is the surrounding, okay. So energy is exchanged between system and surrounding. Like when you just do some things and the energy is lost, but you said that the energy is not destroyed, so because that the energy maybe goes to surroundings, okay. First, let me see endothermic and exothermic. If the reaction is an endothermic reaction, well, endothermic reaction, that means it's absorbed heat in the system. So the temperatures of the system, so the heat is greater than 0 because it's absorbed heat. And endothermic is different. Endothermic is that they release heat into the surroundings. And then the heat is smaller than 0, okay? Units of heat, there's two types. One is calories and one is joule. Okay, calorie is the energy required to make 1 grain of water rise 1 degree. But joule is an SI unit of energy, and 1 calorie is equal to 4.184 joules. Heat capacity and specific heat. Heat capacity is among the heat required to raise the temperature of an object by 1 degree. So something is difficult to change in temperature, okay? So the heat capacity is high. For example, like maybe what you can think of water, it has a relatively high heat capacity. But remember, heat capacity can be different by the amount of things. For example, like less amount of water and less maybe 1 drop of water, so the heat capacity is different. So the heat capacity is equal to the mass times the specific heat. So what is the specific heat? Specific heat is the amount of energy required to make 1 grain of substance rise 1 degree. Okay. For example, Water has a specific heat of 4.18, but remember it is jar per gram and Celsius, okay? And you can replace the jar into calories, which is when you replace it, the liquid water become 1 specific heat, okay? So now we use jars, okay? So water liquid form is 4.18, and water in solid form, which is ice, is 2.06, and water in gas state, water vapor, is 1.87. Ammonia is 2.9, and ethanol is 2.44, and aluminum is 0.897, and carbon in solid, okay, is 0.709, and copper is 0.385, and gold is very small, which is 0.129. So how to calculate the specific heat? First, H equals ms delta T. S is a specific heat, T is a delta T, that means a change of temperature, and M means a mass. So first, how to do it? So 50 grams of piece of something, a metal, absorb 134 jars of heat rising to 24 degrees Celsius to 62.7. So how to calculate? So first, H equals ms delta T. So the H is 134. The M is 15 grams, they tell us. And the S is the things I'm going to calculate. And delta T is a change in temperature, which is 62.7 minus 24, which is equal to 38.7. 38.7 times 15. Okay, so I think calculator is a good thing. So 134 like this, divide 15, which is equal to this number, and then we divide it by 38.7. Ready? Go. Okay. What is about 0.23? Okay, it's about 0.23. And this is jars. Why? Because that, this one is jar, so the S will be jar, and the per gram and Celsius. And what is enthalpy? Enthalpy is the heat that contained in the system. Enthalpy change of this delta H. So the heat absorbed and released in the reaction. So endothermic reaction, it needs. Well, actually, this is wrong. This word. The endothermic is endothermic is that they absorb heat, so it is just form bound, not breaking bound. Okay, so this is wrong. And the enthalpy is greater than 0 because it's absorbed heat. And exothermic is that they broken some bound, so they release energy. So the enthalpy is smaller than 0. What is calorimeter? Calorimeter is something that used to measure the changing heat. So this is a reaction, and then the heat is gave off, and then something just spins to make all the temperature is spread equally. Okay, and then it's a thermometer, so you can know the changing heat. So 24 minutes of 1 big MHCl at 25 Celsius and into 25 cups a meter, and it rises to 32. So it's an exothermic reaction. So in 1,000 jars of this reaction, the solution are 1 gram. Okay. And just assume, and the specific heat is same as water, which is also 1. So it says that assume the solution are 1 gram per ml. So actually, the units are a little strange. You can also, yes, this one is right. You can also say it's 1 gram per cube centimeter cube. Okay. And first, let me see. So 25 we change into gram. We times this 1 is equal to 25 and plus another 25, which is equal to 15. So 15 is the M. High S is assumed is ambient water, which is also 1. So now this is 15 times delta T, which is 32, minus 25, the original one, and found it is equal to 42. This is 7 times 15 is equal to 340 calories, and then we times 4.15, it becomes about 1,500, and it's actually 1,000 jars, so we divide it by 1,000, becomes 1.5 thousand jars. But we got a negative because the enthalpy is smaller than 0. That means that it's an exothermic. And exothermic, that means that you have to change it into the enthalpy. The changing enthalpy is smaller than 0. So it is negative 1.5 thousand joule. Okay. So thermochemical equation is a chemical equation that includes the enthalpy change of the reaction. So what does that mean? For example, you see those equations, this too. First, if you write it like, first you write in plus an energy, but usually when we write the chemical equation, we don't write energies. Sometimes, so we just write something like this, okay? Or so you can represent like this. Delta H is equal to minus. Why is minus? Because it's an exothermic reaction. That means that it is a negative number. That means that the enthalpy is smaller than 0. Like this. So you can write it like this, negative. This one is an endothermic because then the temperature is at right here, the energy. So it is a positive number, so it's just, if you write as this, delta H is just equal to 177.8 thousand jars. So stoichiometry, calculate them. So first, know this equation. Okay, so I think I see the equation. Okay, yes, the same equation. No matter. Okay. So now, 2 more of the methane is released. So so 2 more. So that means that energy have to times 2 more, 2. So the coefficient is 2. So 2 times 898.4 is 1,000 jars. Is equal to this 1,781,000 jars. Sulfur dioxide gas is burned and becomes sulfur trioxide. 58 grams of sulfur dioxide with an excess oxygen. What is energy? So first, sulfur is 32 plus another, the oxygen is 16 and another oxygen is 16, 64. 58 divided 64 equal to this. But now, when you see this 2 sulfur dioxide plus 1 and only 1 energy, so you have to divide it by 2 this, and then we times 198, which is equal to 89.73. Okay, and it is done. Bye bye.